Have you ever stopped to think about how, well, everything around us gets made? I mean, from the phone in your hand to the bridges you drive over, there's this invisible system at work, a kind of secret recipe that turns a simple idea into a real thing. In this explainer, we're going to pull back that curtain.
Okay, so this sounds like the start of a bad joke, right? You've got this incredibly complex piece of aerospace engineering, a super smart device, and something that just brews your morning coffee. What on earth could possibly tie these things together?
And there it is. That's the answer. It's not a lightning bolt of genius, and it's definitely not magic. It's a structured, repeatable process for solving problems. And it's the hidden engine behind just about every product you use every single day.
So if there's a system, there's got to be someone running it, an architect, if you will. So first up, let's meet the main character in this whole story, the engineering designer.
Now, this job is so much more than just sketching out cool-looking blueprints. An engineering designer has a huge amount of responsibility. I mean, the choices they make on day one, literally day one, can lock in how much a product costs, how it impacts the environment, and how well it works for its entire life. They are, no exaggeration, the architects of our modern world.
Their job basically breaks down into these key stages. Conceptualizing is the big picture, what-if thinking. Then, embodying is where they start to give that idea a rough shape, a skeleton. And detailing is exactly what it sounds like. They get into the nitty-gritty, figuring out every last measurement and material. And all the while, they're constantly running numbers and gathering information.
You know, what's really interesting here is that it shows design doesn't always mean inventing something brand new from scratch. An original design is that rare breakthrough, but way more often it's adaptive design, like taking a car and making it more fuel efficient. Or even simpler, variant design, like offering a phone in a few different sizes. A good system has to be flexible enough for all three.
So how did we even get here? This highly structured system didn't just pop into existence. For centuries, design was treated way more like an art, a craft that you learn from a master. So let's take a look at the slow search for rules that turned it into a science.
You can see the very first hints of this way back with Leonardo da Vinci. He didn't just draw one flying machine. He sketched dozens and dozens of variations, trying to find the best approach. But the real shift happened during the Industrial Revolution. Thinkers like Rettenbacher started writing down actual rules. Make it strong enough, stiff enough, but for crying out loud, don't waste material. This was like the very first draft of the design playbook.
All right, let's jump forward to the 20th century. This is where a few key pioneers took those scattered early ideas and really started to build the structured playbook that designers all over the world rely on today. And this quote right here, this is the light bulb moment. Back in the 1920s, an engineer named Vogelbauer had this vision. He basically said, stop trying to solve the whole problem at once. Break it down into smaller pieces. Solve those, then systematically try out every combination of shape, material, and how you make it. For the time, this was absolutely revolutionary.
Right after that, a guy named Kesselring adds another crucial piece to the puzzle. He realized it's not enough to just have 100 ideas. You need a way to pick the best one. So he came up with these principles of optimization. All of a sudden, designers had a scorecard. They could actually compare their ideas objectively.
Then Rodnacker came at it from a completely different angle. He said, whoa, hold on. Before you even think about the shape of something, you have to figure out the physics first. What's the energy doing? Where's the material flowing? Get that fundamental process right, he argued, and the logical form of the object will naturally follow.
And then there was Hansen, who kind of brought a lot of this thinking together into one universal system. His 4 steps, analysis, search, improvement, and evaluation, created this simple, repeatable loop that could be used for any design problem, big or small. He basically created the universal playbook.
So where has all that history gotten us? Well, all that pioneering work didn't just sit on a shelf. It all came together to create the standardized, modern approach that is today's design playbook. Let's have a look.
First, a really important distinction. There's design science and design methodology. Think of it this way. Science is the why. It's understanding the deep rules of how things work. Methodology is the how. It's the concrete, step-by-step action plan. It's the difference between knowing the theory of combustion and having the IKEA instructions to build an engine.
And this is what that how looks like in the real world. This is a common modern process, and it's a direct descendant of everything those pioneers worked on. You can see their ideas in every single step. Figure out the problem, break it down, brainstorm solutions, evaluate them. It's a clear, logical roadmap to get you from a fuzzy idea to a finished product.
All right, so we've met the designer, we've walked through the history, and we've seen how the system works today. But that really brings us to the biggest question of all. Why does any of this matter? Why even have a system in the first place?
Because a good system does all of this. A lot of people think rules kill creativity, but it's actually the opposite. A good framework frees you up to be more inventive. It helps computers do the heavy lifting, it saves a ton of time, prevents catastrophic errors, and it lets huge teams of people all work together toward the same goal. But maybe the most important thing? It turns design from some mysterious talent you're born with into a skill that can be taught and learned.
So, if you only remember one thing, make it this: systematic design is the bridge. It's what connects that unpredictable spark of a good idea to an actual real-world product. It takes that fragile little idea, protects it, grows it, and turns it into something reliable that you can actually build and improve upon.
And that leaves us with one last big thought. This incredible system for creating things is what built the world we live in now. But today we're facing totally new challenges, right? Things like sustainability, recycling, a circular economy. So the real question for the future isn't just about what new things we're going to invent, but what new systems for designing will we need to create to make it all possible?